Hello pre-calculus students, and welcome to the video or lesson on proving power reducing identities. And in this video we're going to prove this statement, but something a little bit different here. This says derive. Okay, so when we work with identities, there's kind of two ways that we can come up with new identities. One is to guess and then prove, and then another is to derive, which is to start with a known identity, adjust here. So start with a known identity and then use algebra to rewrite. Okay, and I want to show you what I mean by this. So if we look at our list of identities here, you see in here that I have in this particular example, I'm trying to prove that cosine squared is equal to this expression on the right. And in my list of double angle identities, I have this statement right here that has a double angle and a cosine squared in it. We already proved this one in one of the previous videos. So if we can just take this one and rework it a little bit, we might be able to get this statement here. Okay, so basically I'm going to forget about this for a moment, and I'm just going to say cosine 2u is equal to 2 cosine squared u minus 1. Okay, and I'm going to make a note here that this is already proved. So you can see one of the other videos to see the proof of this. Now, because it's already proved, I am allowed to move things back and forth on each side. If I didn't prove this yet, there's no way I would be allowed to do this. So because it is already proved, we can move things back and forth on each side. Okay. So I'm going to then just add 1 to both sides. And then divide both sides by 2. And then I am going to just kind of rewrite this a little bit. I'm going to write this as 1 plus cosine 2u over 2 equals cosine squared. Okay. And if you look at this right here, it's the exact same thing as what we have up here. And this is going to look a little bit weird, but just to be very specific and very clear, we are asked to prove this statement. We're not allowed to move anything back and forth in this statement, okay, because we're asked to prove this. But we have something that we already proved, so we can move things back and forth in here. So it's perfectly fine to move things back and forth in this equation because we already proved it, and that eventually gets to this equation. And so there you have it. This is more of a, we call this, it's a derivation more so than a proof, but they're very close and they're similar to each other. A derivation is probably easier to do because it just involves moving things back and forth algebraically on different sides of the equal sign. Whereas a proof, you kind of have to think of many moves ahead in order to really get the correct solution. And as always, these proofs here hopefully are a little bit gentler than the ones you've seen before, but if you still have a hard time with it, as always, ask your teacher for help, be patient, and keep working at it. Thank you for watching. Have a wonderful day.